Hi guys, and welcome to using the discriminant of a quadratic equation. Okay, so you'll be asked to do one of two things once you're given a quadratic equation. You'll either be asked to factor it or you'll be asked to solve it. Now there's more than one way to solve a quadratic equation. You can factor it, that's one way. Okay, you factor it and then you'll set the factors equal to 0. Or you can just go straight to using what we call the quadratic equation, and that's this right here, that x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay? This is especially good to use when you have quadratics where you're given the something with a leading coefficient here with a number there with the a, because when factoring these is a lot more time consuming than factoring something that doesn't have a leading coefficient. And so if you're asked to solve, instead of having to go through all of that, it's a lot easier just to plug stuff into the quadratic formula and figure it out that way. Okay, so there's this part in blue. This part in blue here is what we call the discriminant. This is going to just give us certain information about how many solutions we're going to have and what kind of solutions they're going to be. So right now we're just going to look at the discriminant of the quadratic equation for a couple of examples. So let's go ahead and we'll start with number 1. Now remember that all of these are in this form right here. ax squared plus bx plus c equals 0. So here a is going to be 2, b is going to be negative 8, and c is going to be 9. So what we're going to do is we're just going to plug that into just this part here, just the part that's in blue. Okay, so we're going to start out with b squared. So we're going to start out with negative 8 squared minus 4, and that 4 just came from right here. It's just part of what we're plugging in, times a, and a is 2, times c, and c is 9. Okay, so now we're just going to simplify this. Negative 8 squared is going to be 64, and 4 times 2 is 8, and 8 times 9 is 72. So that's going to be 64 minus 72, and when we actually go through and do that subtraction, we are going to get negative 8. Okay? And the fact that this is a negative 8 right here, what that tells us that it's negative, since it's negative, is that we are going to have two imaginary solutions. We don't know what those solutions are yet. We'd actually have to plug it completely into the quadratic formula to find them, but the fact that the discriminant is negative means that we're going to have two imaginary solutions. Okay, so on to number 2. Let's look at number 2 now. Okay, so we're going to do exactly the same thing. We're just going to look at plugging these numbers in exactly the same way. Okay, so for number 2, we're going to have, again, for number 2, b is negative 8, so we're going to have negative 8 squared minus 4 times negative 2, sorry, positive 2, that's a is positive 2, times c, and this time our c is positive 8. All right, so let's go ahead and work that out. Again, negative 8 squared is 64, and then 4 times 2 is 8, and 8 times 8 is 64. So I end up with 64 minus 64, which is, of course, 0. And anytime we get 0 here, that's going to tell us that we're going to have one real solution. One real solution. All right, and then finally, we've got our third example here. We've got number 3. So we're going to do the same thing. We're going to plug in for number 3. We're going to plug in, oh, I don't think you guys can see that, can you? We'll do it over here. We're going to plug in b squared, so that's negative 8 squared, minus 4 times 2 times 7, and that's going to give us 64 minus 4 times 2 is 8, and 8 times 7 is 56. So we're going to get 64 minus 56, which is going to give us a positive 8. So the fact that that's positive is going to tell us that we are going to have two real solutions, okay? So the discriminant tells us that we're going to have one of three things. If it's negative, we're going to have two imaginary solutions. If it's equal to 0, then we're going to have one real solution. And if it's greater than 0, if it's positive, then we're going to end up having two real solutions.